Hi everyone, my name is Carlos Balmaceda and welcome to my YouTube channel, SQL Portfolio, where I want to help you become a skilled data analyst and create an impressive portfolio. In this video, I'm going to go over the join function. The join function in SQL is used to combine rows from two or more tables based on a related column between them. It enables data from different tables to be linked together. Imagine there are two companies that merge to create a dominant alliance. However, they face a challenge. Their databases were built on different systems, data structures, and formats. As the merger progresses, they need to integrate their customer databases. That's when the join function becomes invaluable. With its capability to combine data from different sources, the join function helps align customer records across the newly united company. Let's go ahead and take a closer look. In this hypothetical scenario, we have company A and B merging. During the merging process, each customer will be given a unique customer ID. We will need to use the join function to merge the information for both companies. Keep in mind that there are four main types of join functions. Since companies normally use the full join function when they merge, let's go ahead and start with that one. The full join function returns all the rows from both tables and it fills the null values where there are no matches. Let's go ahead and take a look at this in action. I'm going to use BigQuery for the SQL program. However, most syntax are similar no matter which SQL program you're using, so you can still follow along. Here we have two tables for company A and company B. Both companies have columns for the customer ID, name, and email. However, company A has an additional column for the department, while company B has an address column. To consolidate all the data for both companies, I will use the full join function. Let's take a look at the syntax. First, we use the select clause to specify the columns we want to include in the result. Because I want the customer ID for both tables to be in the same column, I'm going to use the coalesce function. The coalesce function takes two arguments. In this case, the column for A.customer ID and B.customer ID. It evaluates these arguments in order and returns the first non-null value. If you want to learn more about the coalesce function, click on the link above or check out my video, coalesce function. Moving on, the from clause specifies the table names for company A and B, and the as keyword is used to assign aliases to the tables. That way, when I join the tables, I don't have to type the entire name for the table. Instead, I can just type A for company A and B for company B. The full join clause performs the join operation. This will allow us to join the table for company B to company A. The on clause specifies the condition for the join. In this case, we will use the customer ID to join the tables since the joining column needs to be unique. For instance, each customer has a unique ID. However, using the name as the joining column would not be reliable, as multiple employees could share the same name, leading to potential data inconsistencies. By running this query, we can effectively combine the customer ID from both company A and company B into one column named customer ID. We also have the name, email, and department columns for company A and the name, email, and address for company B. Just as we did with the customer ID, we can utilize the coalesce function again to unify the name and email columns for both companies. Let's see what that would look like. Now we only have 5 columns, one for customer ID, name, email, department, and address. We discussed how a full join returns all the rows from both tables. Now we're going to discuss the inner join function. It returns only the rows that have a matching values for both tables, as it filters out rows that don't match the condition. Let's take a look. Here, we kept the same exact syntax, except we changed it to inner join from full join. The syntax pulled 2 rows, so this lets us know that both Mike and Laura worked for company A and B. Using the join function also eliminates any duplicate values. You can see that we don't get 2 rows for both Mike and Laura. Next, we will discuss the right join, which returns all the rows from the right table and the matching rows from the left table. Let's see what that looks like. Here, we have all the data from company B, but not company A, as we have all the values for the address, but not the department. Here we will use the left join, which returns all the rows from the left table and the matching rows from the right table. Here we can see that now it's the opposite. We have all the data from company A but not company B, as we have all the values for the department but not the address. I know this is a lot to take in. Here I have the data from company A and B and all the 4 joins side by side, so you can pause the video and compare the data. In conclusion, we've explored the full join, inner join, right join, and left join. Each join serves a specific purpose in combining data from different tables based on common keys. By understanding the join types, you can efficiently merge data sets, extract relevant information, and gain valuable insights from complex databases to enhance your data analysis and decision-making process. If you are interested in creating a comprehensive case study that you can showcase to prospective employers, click on the link above or check out my video, Master Data Analysis and Create an Impressive Portfolio. Lastly, if you found this video helpful, please consider liking the video. Your support not only helps the channel, but also helps me create more content. I hope I was able to earn your thumbs up, and thank you for watching.